So welcome to the GEO Dialogue series. You are here in the second dialogue. We had one last week on the data cycle. And this week we will talk about the data sharing principles. We will have one dialogue each week to talk about each of the data sharing and data management principles. I will share my presentation. I am Marie-Françoise Voidreau, and I co-organize this dialogue series with, of course, this is organized by the GEO group on Earth observation, but Bente Liliaby and I are implementing these dialogues. So please mute your microphone. This session is being recorded, and the recording will be presented on the GEO website in the GEO Knowledge Hub. If you want to intervene, you can raise your hand. It's under reactions, and you can wait for the moderator to give you the floor. So what is the dialogue series? The GEO data sharing and data management principles need to be advocated. We have seen that from several projects. People very often know about them, they have heard about them, but they don't really have a deep knowledge of each of them. Or maybe they just know the first ones and not the last ones. Then the GEO Data Working Group has decided to make this dialogue series to raise the awareness about the principles, their expected benefits, and invite members from the Earth observation community to showcase their implementation and bring their experience. This is why each dialogue will have a theoretical presentation of the theoretical principles and then success stories to simulate the brainstorming and to allow this big community to map and understand what we talk about in your own context. These dialogues will be recorded and published, as said before. And what we want to do is that we want to revitalize the engagement, because it's very important now to share in situ. And we need to mainstream all these concepts and principles to a much broader community. So this is why we thought that this is the really good moment to implement these dialogues. So the perspective, of course, as said before, is that we want to encourage the share of data, and especially of in situ, but we want to talk about law and policy, because we know that this is something that can prevent the sharing, and this is why this dialogue is very important to us. And of course, we want to bring some GEO work program examples about the application of all these principles. Don't worry, you will have a slide that will explain each of the principles into the presentations, but these are the data sharing principles that we will discuss today, and I will let Bente present them just after, so we will not go into the detail right now. These are the different data management principles. We will make one dialogue about the first one, one about the second one about the usability, this group of the 4 principles, one about preservation, and one about curation. This is the roadmap for the dialogues. So we had one about the data lifecycle. Today we are here, and these are the dates.
Sorry, Marie,
yes?
Are you sharing your screen?
I thought I was sharing, but you're right, maybe not. Let me check that. Thank you. Is that better?
Yes.
So here you have the roadmap about the different dialogues, and we invite you to save the dates. It's every Monday at the same time. And the idea is always the same. We'll have a panel of speakers that will stimulate the dialogue and the brainstorm, bringing their experience, and a presentation of the theory of the topic, and then a presentation of success stories and discussions. So today, the agenda will be an introduction by me, who I will moderate the session today. Bente is going now to introduce the GEO data sharing principles, looking back a bit of the history, how we arrived to the situation we have right now. Then we will have a presentation from Barbara Ryan and Daniel Quintin, from Barbara Ryan from the World Geospatial Industry Council, but she was very involved in the Landsat industry before, with USGS, Daniel Quintin for Copernicus. We will make some polls to engage with the audience, and please contribute to the polls, because it will help you think about how can this apply to your activities. We will talk, we will have Kate Weber from Google, then Einar Gorgo from the United Nations Satellite Center, and Lars Peter Richersgaard from the WMO data sharing. We will talk about WMO data sharing. Please do not hesitate to use the Zoom chat if you have some question or comment, and we will do some polls where we invite you to answer. So this is just a brief presentation from me. I work with the Open Geospatial Standards, Open Geospatial Consortium, sorry, and I work with the Innovation Program, where we try to take scenarios and to be very pragmatic to build solutions. And OGC is well known for its standards, and when it is needed, we build standards for that. So Benta is going to be our first speaker. So Benta has been a member from the GEO community since 2004, and she has been a research director of the Norwegian Mapping Authority, and she's engaged both as a representative in the GEO plenary, in committees, and she contributes as a very active member of several GEO working groups and initiatives in the work program. Benta, I let you the floor.
Thank you very much, Marie-Françoise. I will share my screen and introduce and remind many of us of the GEO data sharing principles. So it's based on a political initiative. It goes back to the World Summit on Sustainable Development in Johannesburg, 2002, and also the plan of implementation and the G8 ministers meeting in Evian. And there was consensus at these summits that we needed to enhance current observational networks globally. So the US took an initiative then for a meeting in August 2003 in Washington, D.C. And there was some 30-something countries that met and decided to follow up on Earth observation summits to create GEO. And one of the things that was we wanted to do, and I say we because I was actually part of the many people, the group of many people who wrote this reference document for GEO, where to enhance the observation networks, it was a matter of not having unnecessary duplications of resources, and also to identify gaps and share the responsibilities of filling those gaps. So, and that led to the first, what we called for a long time, the GEO's data sharing principles. And some of them are similar to what I will show you the second one, or the current one shortly, but we agreed to share data and metadata and make it available with minimum time delay. And we also recognize that it's not always possible to share the data for various reasons, for security reasons, economic reasons, and various policies. And we are going to discuss some of these issues today. And the first one, it was we agreed to share data, metadata, and products for use in education and research, and also not charge more than the cost. And what I particularly find interesting in the first documents that we created, that even though we share data, it doesn't mean that we agree on the interpretation of the data. I thought that was an interesting twist in the discussions we had. So the second one, so this principles, they were approved in 2005, where we had the public, the creation of GEO. And we were 61 member countries, and I don't remember exactly how many participating organizations, but the point is here that this is on governmental level. We agreed to follow these principles. And for those members have been growing continuously, and everybody that committed to be a member of GEO also committed to these principles. In 2015, we had an update that strengthened this open data sharing principles in the next 10-year period. Remember, we in GEO, we have 10-year implementation plans. And so we are now currently in the second 10-year period, and we have the 2015 to 2025 strategy to follow now. And we go, I want to point to a couple of things here in the of change, difference between these two sets of principles. We went from not only sharing for education and science, but by default, we agreed to make the data free and open. Free and it's not free, but it's to as low cost as possible still. And we should also, it was emphasized that it should not be restrictions on the reuse either. And we emphasized also minimal restrictions, and we continued the minimum time delay. So we have strengthened the and made it more open these principles in GEO. I forgot to put the number who agreed to this 2015 principles. It was 102 members at that time who approved these principles. That is the current principles, and as of late, we are no longer calling them the GEO's data sharing principles, but the GEO data sharing principles. So here they are in a form that you will have seen several times now, in a more easier to consume, I guess, data management, the data sharing principles. Now, so we started in 2003 to discuss it. We approved the first set in 2005, and we have a revised set of data management, data sharing principles in 2015. Now, in last year, we went even further. We are moving towards the future. We agreed on the GEO Open Knowledge Statement that goes even further. It's composed of several open practices. It's based also on the UNESCO recommendation on open science, but GEO is more than science. So we adopted and tailor it to our community. It goes also beyond open access. It includes societal issues, not only technical aspects, and it considers all the research and output and effort. So this will point into the direction of the future. And that's why we also have the Open Knowledge Hub, which will be covered in a later dialogue, I believe. But this is just a short overview of the history of the GEO data sharing principles that we are so proud of. I have to say, this is like what we hold up as see what we have done in GEO. So thank you very much. Marie-Françoise, are you speaking?
Yes. So any question to Bente or any comment on what she has presented? So we will go to the next speaker. That this will be Barbara Ryan. Everyone knows Barbara because, of course, she was the previous GEO director. GEO being the secretary, she was the secretarial director for the Intergovernmental Group on Earth Observation. But before that, she also has been the director of the World Meteorological Organization Space Program, and even before, she was involved in USGS into the Landsat policy, and this is the success stories we invited her to present here. Now she's involved with the World Geospatial Industry Council, so she have a broad overview from a long period of time of the evolution of this data sharing and knowledge sharing. So we will give you the floor, Barbara, if you're ready.
Well, great. Thanks so much, Marie and Bente. Great seeing you again. Let's see, let me share my screen. It said I couldn't do it when you guys were sharing. Let me know if you're seeing something. Let's do slideshow.
Your screen?
How about there? You seeing it?
Yes.
Okay, I don't actually know. Maybe if I remove that there, does that take people's pictures out of the way so that you can see the full screen?
Yeah, we can see the full screen.
Okay, perfect. Well, listen, thanks everybody. And I'll try and keep to the allotted time. I really just want to talk about the importance of open data. And clearly we'll use Landsat as an example, but I want to tie it back to what GEO is doing, and then also some of the global policy initiatives that I'm arguing are going to rely on open data. So let's see so first of all, this is a slide we often use that just talks about either trends in geospatial and Earth observations. Open data is what I really want to focus on here, although we'll spend a little time talking about technological advances. Clearly, GEO is all about better integration and coordination and hyper partnering, but I will come back at the end of the talk to this linkages to the policy mandates. So let's just look at the experience in the United States with the Landsat data policy. This graph starts in 2008, but the first Landsat satellite was launched in 1972. It's its 50-year anniversary this year. In fact, the Pecora conference in Denver in another month is going to be celebrating that 50-year anniversary. And so from 1972 all the way to 2008, the United States sold Landsat data. It was $400 or $500 a scene when the public sector sold the data, USGS. It was $4,000 or $5,000 a scene in the mid 80s when the satellite went back to the private sector for operations. And then we finally were able to make an argument that over that entire time, from 1972 up to 2007, only 53 scenes a day were being sold. Now, if you take those 53 scenes by $400 or $500 by 365 days a year, the Geological Survey was taking in $4.5 or $5 million. And that's a lot of money by, any federal agency's perspective. But if you looked at who was buying those 53 scenes a day, number one, the other federal agencies, primarily the Department of Agriculture. Number two, universities that were funded by the National Science Foundation. And number three, contractors that were largely funded by the defense and intel community. So we were just recirculating that $4.5 million or $5 million a year from one pocket to another. So we made an argument, took several years. In fact, there were many people, I would argue, since the beginning of the Landsat program that advocated for broad open data. But it took us several years to finally convince first the Department of the Interior, and then the White House and the Office of Management and Budget, and then Congress that, listen, let's just give the data away over the web. And this is the graph that shows the result of that. So from 53 scenes a day to 5,700 scenes a day, I believe those numbers are higher now. 2 orders of magnitude. We knew it was going to be good, but I don't think we ever expected it to be quite this good. Now, I had already left the organization at the time. I retired in 2008 and took the job in GEO. This economic analysis was done in 2011, and I think this is the real story. The annual economic benefit of that data policy change had an accrual of economic benefits to the tune of $1.7 billion to the United States, 400 million outside the US, for a global total of $2.1 billion. Now that far exceeds the $4.5 or $5 million that the Geological Survey was taking in. So Again, the numbers have been updated, and I honestly, I think these numbers were quite instrumental in having Europe's policy for the entire Copernicus program, and the Sentinel satellites also moved to broad open data. So tremendous economic story about the importance of broad open data. But you know, it's not just the economic benefits, it's also tying these in with the technological advances that are occurring. And if you look at this animation, this is what Australia did with their data cube, where they ingested the entire Landsat archive into their National Computer Center. They have since brought in all the data that Copernicus and the Sentinel series of satellites have. They've superimposed a water algorithm over the entire continent that said, show me every pixel, not every scene, but every pixel. So 30 meters by 30 meters of area on the whole continent of Australia that's always been wet, always been dry, sometimes wet and sometimes dry. So you'll see a histogram that is actually been done for this one square, but think about the entire continent of Australia that has this algorithm all on top of broad open data. They would not have been able to afford buying that Landsat data at $400 or $500 a scene, because it took on the order of 300,000 scenes to do this continental scale analysis. 20,000 passes. Look at the terabytes of, look at the petabytes of pixels. And then if you got it down to 3 hours of compute time. So whether it's in your National Computer Center, whether it's in the cloud, what we're arguing is these large regional analyses would never have been possible if you weren't able to get access to broad open data. That's Australia's story. You know, if we look about the linkages to these policy mandates, whether it's the Paris Agreement or the Sendai Framework or the SDGs, we're arguing you need access to this information. Just look at some work that the European Commission has done through their JRC that just points to spatial patterns of inequalities around the world. Can you imagine the power of being able to superimpose this population data, the water algorithm that we saw with the Australia example, soil moisture, all the in situ data that Bente made reference to? If we want to deliver those sustainable development goals, we've got to move towards broad open data, not just for space-based assets, but for all assets. So in closing, I just want to say, while I'm with WGIC, the World Geospatial Industry Council, which is a not-for-profit organization, but working on behalf of the private sector for a number of different reasons, strengthen the contributions of the industry to society and the global economy, of course, advance policy matters, and create business opportunities. I want to take this opportunity to say, while you look at our member companies that are part of WGIC, not all of them, but a fair number of them are in fact, if not opening up their data more broadly, they are in fact creating programs within their companies, whether it's for conservation purposes or for forest needs. Planet's example of tropical rainforest. We are slowly seeing private sector companies, if not opening up their entire assets, they are opening up selected assets for researchers or conservationists around the world. So I think that's my last slide. Bente and Marie, I hope I kept it within 7 minutes. My address, if anybody needs it. And again, thank you so much for reaching out to me and to WGIC to participate in this really important dialogue. Actually, I will say one other thing. when the US announced that Landsat data policy change, they chose a GEO meeting to announce that change. It was the Secretary of Interior that traveled to South Africa for the South Africa plenary in 2007 or 2008 to announce that change, because they knew there for a change like this, because it was one of the first major satellites to go broadly and open with all its data. So it's great that more GEO members are following in that path. Thanks so much. I'll turn it back to you guys. Bye-bye.
Well, thank you very much, Barbara. I think you have demonstrated that Landsat was a real success story with all your graphics. You have shown also the power of Earth observation open data and the value which is still to be revealed if we have more open data from other fields that we can combine with open data. I have a great news is that we have amazing panel of experts, but we also have an amazing audience, because I started the first poll and we already have 70% of answers, meaning that the audience also wants to share his experience. The next talk, and you will have time to ask a question to Barb. Do not hesitate to put questions in the chat. It's always inspiring to listen to our experts. So the next talk will be from Daniel Kenta, who is a legal expert with the European Commission, and he has joined the European Commission and the Copernicus program in 2011 to draft the Copernicus data and information policy. And you know how important these data are for us in Europe now. Daniel, are you ready?
Yes, indeed. Thank you. I'm going to share my screen. Certainly. Okay. First of all, I must say thank you very much for those presentations before, because indeed, I mean, what has been said is really fully in line with what Copernicus is doing. And in fact, we have really followed the cue from Landsat for its policy. I hope you just see that slide, which is the Copernicus slide, showing the observation from the space infrastructure and the in-situ infrastructure. Then the different services that Copernicus is using to generate information on atmosphere, marine, land, climate, emergency, and security. And this is for users, policy, public, and commercial. What is interesting here is that we wanted to have a free, full, and open data policy. We want it for the space infrastructure, the Sentinels, but we also wanted to have it for the service information, the information generated from the different services. From the space infrastructure, we had the Sentinel data that were launched from 14 onwards. And for this, of course, this is the asset of the EU, and therefore we could put a free, full, and open data policy on it. But we were also using other satellite data from commercial missions or other missions with a specific data policy. And for this, of course, those ones, they were limitation. We had to negotiate with those provider of data the possibility for the services to generate information from those restricted data to be able to distribute everything under a free, full, and open data policy, everything but the data, of course, the restricted data from those missions. Most of it, as I said, is free, full, and open. There are some limitations, though. I just mentioned it. When coming into the system, you have a IPR restriction on the data. Those data cannot be free, fully, and openly distributed, of course. And then there is another restriction which could be from security. And you see in all those 6 Copernicus services, it would only apply mostly for the security services where the information is getting into specific channels for users that needs to know. All the other are usually on free, full, and open without any security restriction. It's even extremely important. Of course, if you take a service like climate change, it is very important that everybody can have access to the data that's coming in the service, and also access to the information out of it, just to be able to check on those observation and information to see that it's of the soundness of those information. So basically for Copernicus, from the first data policy that was in 2013 and onwards, we had different regulation, because each time there is a new finance regulation, we need to update our regulation. And each time the principle of the free, full, and open was reused and even more developed to serve our users. There's proved to be a real, I would say, a real success for Copernicus to be able to provide those data and information from the users. Barbara has shown this, what the Australian has done with the data cubes. I mean, there are plenty of examples of that sort. And I must say that this was a real boost, and I'm a bit thankful for the one initiating those distribution, and Landsat in particular distributing the data, the satellite data. And I would conclude by this my presentation. Thank you very much.
Well, thank you very much, Daniel. It's very important to show that Europe has followed this movement of opening data. You have enhanced that Copernicus services are very user-driven, and this is very important. It's a trend that is developing. You also introduce the concept of data, but also information. So it's not only data we are talking about. Bent has introduced the sharing of knowledge and much more. And it's nice to have all this opening to brainstorm. The next presentation. So first, excuse me, I should share the results of the poll. So I will take the screen for 1 minute. And I can, if I share the results, do you have them on your screen, or do I only have them myself? You can see the results or not?
Yes, we do.
Yes.
Okay.
The results, yeah.
So, so 89% of the participants consider that the open data is critical to their work or business. This is just amazing. And we thank again all of you contributing to share this data, because we can see that it is working, it is developing work and business. And some of you are not using open data. I think it's just because you need to learn more about all the open data which is available, and just 3% of you do not know. Thank you for your answers. I think it was very, very interesting for us. So the next presentation then would be from Kate Weber from Google. We know that if we want to share data, it's because we want this data to be used. And Search Engine and Google, among them, are very important to find the data and access the data. So I will let you the floor, Kate.
Thank you very much, Marie-Françoise. And I'm just going to share my presentation quickly here. Now I need to stop sharing the audio from the presentation. I think I'm set. Can you see that?
Yes,
yeah.
we can see the screen.
Yes.
So, yeah, so coming with a bit of a different perspective from Google, but the GEO open data sharing principles are very aligned with Google's views on open data in general. And as Barbara mentioned, I think many companies are thinking about sharing more and more data. And so I'm just going to talk very briefly about Google's work in the open data space, and then kind of the policy and legal challenges around making more data accessible and useful. And the accessible and useful piece is a play on Google's mission, which is, of course, to organize the world's information and make it universally accessible and useful. So as you can imagine, that open data fits in very well with this broader mission. At Google, of course, much of our open data work is in the AI machine learning space, which is where most of our research is centered. And what I'm going to do today is just give you a brief overview of the kind of number of data sets that we've shared. You can see on the slide. I won't read it to you. But I'll just note that we generate our own open data sets. We also host open source data sets on Google Cloud Platform, and this includes many, for example, US government data sets. We have a lot of NOAA data sets on GCP, for example, which allows faster access and access to our cloud servers for that data, which we've heard from some government agencies is very helpful. This is a quick snapshot. There are some acronyms in here, I know, but we have the data sets that Google creates. You'll see many of these categories, again, are related to machine learning, computing, a few related to environment and public health. And just a few examples to give you an idea. Some of our open data sets are very widely used amongst AI researchers. For example, Open Images, which is used for image-based machine learning. This one may be more relevant for the GEO community, was just released this year, land use data at 10-meter resolution. And this is, of course, in partnership with others who help us pull together these data sets. And then we process them with machine learning and share them. We also, in our work, are in open data, in addition to creating, sharing, hosting data sets, we leverage Google's search expertise to help others access more data that is already existing and already open. We have a tool called Dataset Search. And we also have this Google Patent Search is very widely used amongst folks in the patent community. It takes data from over 100 of the world's patent providers, and I think has 120 million or more patents represented in its data. So just a couple of examples. Another snapshot here of those hosted data sets on Google Cloud Platform gives you a sense of the amount that these are accessed by users. And just wanted to compare to the types of data sets that Google creates versus the ones that we host. You'll see here there's many fewer of these are machine learning or ML based, and there's much more in the environment, public health, also finance space. So just thinking about the policy challenges, and kind of many of these will sound familiar to you looking at the GEO principles, but one, I think, challenge that is very stark for us, and I think maybe a little bit unique in kind of this more, I guess, in the GEO community, in situ is kind of a relevant term, but in Google space, many of the data that we're using has privacy concerns. You create a data set of images. There are a lot of protections that have to be taken there around privacy and security. So a big challenge for a company like Google when we make data open is how do we balance the privacy and security aspect with the drive to be transparent, make data open and useful for others. And then, of course, availability. So where is the data? Is it a stable location? Is it easily discoverable? So this is where the Google search expertise, making data more discoverable, and also the ability to help by hosting data sets to make them more easily used comes into play and is important. But of course, these are challenges that are shared across the community. Google isn't going to, nor do I think anybody would want us to solve them on our own, because nobody wants us to be the only keepers of all of this data. Another really big just sort of place of focus for legal and policy challenges, and we see this reflected in the GEO principles too, is formats and standards. Of course, we want data to be both human readable and machine readable. And then the metadata and the data schemas, so like the categorization of the the different pieces of information available in the data need to be standardized as well. Google is involved with an organization called schema.org, which is the most commonly used schema provider on the web these days. It's also many other large companies are involved there. I don't have the stats in front of me, but I think it's kind of upwards of 70% of websites use the schema.org standards for metadata. So just like the more we can standardize that piece, the easier it is for everybody to be creating data sets, common data sets together, using the same data sets and having the same kind of vocabulary around how we do all of that. Related to this, a place that we're thinking a lot about is in the machine learning community, how can we do a better job of having commonly created and shared data sets where many different researchers can contribute their data to a larger corpus of data that is then governed by some kind of third-party consortium rather than one company or one entity creating the data. In our world, there is, I'm sure you've heard, increasing concern about lots of this data being owned by a small number of players. And is there a way that we can democratize that? So that's something that we're thinking a lot about too. And then we also have licensing can be a big challenge. So our position is that licensing should be very clear in all data sets. Often we see data sets where there's no license, and that is the worst possible outcome because then it's really hard to use the data. And where possible, it should be the least restrictive license. So, these are the Creative Commons CC0 and CC BY 4.0 are the preferred licenses for open data. And then another place where we're doing a lot of work is on APIs, where we take multiple data sets and put them together into one API so that a lot of the processing that's required for taking data from disparate sources and putting it into common format schemas, et cetera, is already done. And then we can share that openly and other researchers can access it and avoid all of those processing steps. So we have, for example, a tool called Data Commons, which essentially does that and is very focused on sustainability data in particular, but includes all kinds of data. So I know that we've got very limited time, so that's what I've prepared for today, but looking forward to the discussion and to hearing from the rest of the presenters. Thank you very much for the invitation.
Well, thank you very much, Kate, to highlight Google contribution a little bit differently from what we expect, but Google as a data provider, also as an open source provider. Thank you for enhancing the role of standards to make data more usable and reusable by everyone. And then to have highlighted that open data does not mean no license, that we want to have some license because this makes the data much more usable. Next presentation will be by Einar Bjorgo, and then we will open the floor a little bit before giving the floor to Lars Peter. So Einar is a director with UNOSAT, and I could discover myself that in his bio that Einar enjoys matching technology innovation and solutions with practical benefits. And I think this is very good because this is what we want. This is what is difficult, is to link this theoretical, I would say, policy topic with very pragmatic needs and making this connection. So Einar, the floor is yours, and then we will give the floor a little bit to some discussions.
Just a little bit of background on UNOSAT. We are part of the United Nations Institute for Training and Research, headquartered here in Geneva in Switzerland. And UNOSAT has been operational since 2001, and we were recognized last year as the United Nations Satellite Center. And you can see the mandate that was given to us here on the screen. So that is to provide United Nations funds programs and specialized agencies with satellite analysis, training, and capacity development at their request, which is important to us. And to continue supporting member states with satellite imagery analysis over their respective territories, and to provide training and capacity development in the use of geospatial information technologies. So how do we do this? Internally, we have one unit focusing on training and capacity development, which is very hands-on, very much focused on technical training. We spend a lot of time making sure that our end users, typically people in government agencies, are making good use of this technology. Then we also have our own internal satellite analysis team, and that uses various sources of satellite imagery, so that we make sure that that is also a part of our services. But sort of also as a cross-cutting team here, we also do applied research and innovation internally. But just to focus a bit on the emergency mapping service, of course, we do a lot of so now no longer talking about training and capacity development. We need to focus on this emergency mapping service. Here, the UN got access to the space charter back in 2003. So that is when we started to use it. I remember the first one was flooding in Nepal. And since then, we have been the UN, together with our colleagues at UNOSA, we have been triggering the charter an enormous amount of time, because this is really an excellent tool to benefit especially the countries that we are serving, and also inside the UN system. So typically what we see is that UN colleagues are asking us for help, and we want us to trigger the charter on their behalf. So just a little bit of statistics. I mean, this is just for the last 2 years. Here we have, this is UNOSAT, how much products and services we have done. I would say about 95% of these we have benefited from the space charter. So the space charter is extremely important to us. What does it provide? It provides you with raw satellite data from a wide variety of satellites, national satellites, also commercial satellites, and we have really benefited hugely from the space charter. So most of this work then is related to various, let's say, call it natural disasters. So the space charter is not about man-made disasters. It is really about, let's say, or oil spill, I guess, is the closest one you get to a man-made disaster. But really, we're looking here at various types of other disaster types. So that is why we have, mainly working as UNOSAT in Eastern and Southeastern Asia, and also in Sub-Saharan Africa. We have been doing a lot of work using the space charter. And also just to give you a rough indication of the types of products that we do, you can see here, most of it are maps. We also provide a lot of statistics. We provide vector image sharing. When you see that here, I mean, just remember that the vector and the image sharing that we do is all based on our own analysis. And we basically provide all that information out there for free, because we get the data from the space shuttle for free, and we also make sure that whatever we produce is being properly shared and used by other entities as well. So I wanted to also provide you with one example. We back in September 2001, we were asked by our colleagues at the UN OCHA, the Office for the Coordination of Humanitarian Affairs, and we also here worked with our colleagues at UN ESCAP and also GISTA in Thailand. So we triggered the International Charter on Space and Major Disasters back in September 2021. And we then also used, here you can see those photos that we used is through an app called the UN Assign that people can use in order to also provide input to this. So that is also open source, by the way. And the population exposure estimations and satellite detected water extents were also calculated using artificial intelligence methods. So we do use then the data that we get from the space shuttle, and we put it into various service products. Some of them that you can see here. So this is a typical range of products that we have done in one case. So what you see here is before and after photos. Sometimes we do when in order to just show locally, how things are, but also we use this also to calculate statistics that we include in the maps, and also sharing that information out there. So that is one element. Another element that we use, and this is also using Sentinel-1 data, that we have developed an in-house automatic data flood analysis tool on, and that is also something that we have seen hugely really benefiting the countries and that we are supporting. And of course, the nice thing about this is that we include it into the AI and it's all automatically corrected. However, I want also just to highlight that we have trained these algorithms ourselves, and we only release, and it doesn't work easily everywhere, so we only use it where we know that where the results will be really good. So yes, so we also got very good feedback from what's called the UN resident coordinator of Thailand, and they were also really pleased to see how these tools can then help the government dealing with the flooding as well. And as you all know, big flooding in Pakistan, in various parts of Pakistan, and we have been on this, for the last couple of weeks. Again, benefiting hugely from the space charter. So that is, a bit how we work. But I also want to highlight, the way that we also share data back. So all these data are downloadable, either in Excel format or shapefile, etc. And then we also share it widely. We try to share it as widely as we can. So I think at HDX we're one of the most downloaded data sets come from UNOSAT. And also we share it to Prevention Web and Relief Web as well. So it's really important for us to also to share the data back, and of course anyone can use them. We have anyone can use them, but of course not resell them or anything. We do make sure that we work with these open data standards in terms of the tools that you can use. Also, what we do now is not featured here, but we also use this automatic feeding of data into various GIS systems, such as S3, but also open source data that you can see. And so that, I think, was my last slide. Yes.
Well, thank you, Einar. I think that this example where major stakeholders agreed to have an exceptional process, which is driven by exceptional user needs, but that can be activated very rapidly, and where everything is prepared to be usable through different tools and so on, I think it's, again, an amazing success story. Are there any questions? I think you are a bit shy because I don't see many hands raised, and I'm really surprised that you do not have questions to our amazing panel. Oh, Bente. Apologies.
Yes, I just raised my hand. I can go. I have several questions, but I very quickly will ask a question to you, Einad, because you obviously you sort of have something operational ready to use the data that you get from when you are triggering the space charger. How is that? I mean, you are a UN organization, but the individual countries can also trigger the space charger. Do you have any examples on how you are cooperating?
With the countries?
Yes, at the, when you have an event.
Yes. So typically, when we are asked, it can be also a country can also ask the UN to trigger. Then it's our colleagues at UNOSA that triggers for them. We trigger for the UN. But I would say that we do have it's quite straightforward mechanisms for this, and then of course the space charter itself work a lot on what they called applied users of this. So you have to sort of become let's say a regular user, and for that you have to apply to space charter, because it's some formalities. You must have a specific point of contact and these kind of things. But I have to say it's a mechanism that works really, really well, and we are just very happy to be able to benefit from it.
I have one more question, and that's for Kate. So Kate, you mentioned the APIs and different licenses. I know that if you want to make a product, for instance, one of that, Einad is showing the many different components, so you can have many different licenses. And some of them are stumbling stones if you cannot make it. Do you have any examples on how you have managed to solve these issues in terms of concrete examples?
So usually that's a great question, Menta. I mean, usually it involves a lot of work reaching out to data owners to get the agreements on a case-by-case basis. So, one tool during the pandemic, we had a bunch of researchers who kind of decided they were going to create this COVID open data repository. And they spent many weeks, I think, reaching out to researchers and governments to where there was no clear licensing information to get that approval. There were lawyers involved. So yeah, I don't have there's no good solution, I think, other than a lot of work when the licensing information is not clear, which is why it's super important to make it clear. Yeah.
Thank you.
Thank you. Thank you, Einar. Thank you, Kate. Carl, you had a question?
Sure, thank you. Yeah, I also had a question for Kate. As one of the interesting challenges is what I see sometimes as a trade-off between the ease of access and distribution through cloud platforms like Google's and the agreements that are also in place with some of the other cloud providers, and how that connects to or brings in the idea of persistent identifiers that are typically provided by long-term repositories that include a preservation component. Thinking of the comment that you had on one of your slides in terms of data should be available at a stable location, online, easily discoverable, that doesn't necessarily suggest the long-term preservation or the ease of citation that is normally associated with persistent identifiers. So how do you see potentially the complementary roles of the open data access that Google is providing as it relates to that long-term preservation and citability?
Yeah, that's a good question, Carl. I think hosting data on a cloud platform doesn't preclude it having like a DOI, right? So you can still, and you should, ideally, all of that data does have a persistent identifier. And for much of that data, for the government example, certainly, It's also hosted on the government website, but the cloud platform is, I think, a useful tool for users who need like high volume, who need to access it a lot, basically. It's not a perfect solution. There's a lot of work going on in the AI community right now in the US, for example. There's a government task force called the National AI Research Resource Task Force that's kind of laying out a vision for a national cloud resource where the government could facilitate making available data compute resources in a more equitable way for all researchers in the field. Because of course, there are very real concerns with a provider like one cloud data provider kind of having control what happens if the data moves, right? There are concerns around privacy, who is able to, on Google Cloud Platform, there's a certain level of access that's free, but once you use a certain amount of compute, then of course you do pay for it. So then it becomes, the data is accessible, but like using it in certain ways incurs costs. And so how do we make all of this more equitable? And those are ongoing conversations, and Google is a part of those, as are other cloud providers. And I think a lot of people are hopeful that we can find solutions. I maybe rambled on a bit past your initial question, but hopefully
Well, I think that helps to describe the shape of the landscape we're operating in. I work in a university where we're supporting researchers and still working on trying to help clarify for our researchers, what it means to share and cite the data that they're using or producing, and the availability of cloud-based storage and access endpoints occasionally confuses some of the researchers we're working with for their project data. And this is just an ongoing education and capability development process. But I was curious, since you were here, is a good point to ask it.
Yeah, and I think these policy, like this national AI research conversation, is also about getting these resources to more different research communities too, beyond just the core kind of AI community. So yeah.
Thank you.
Thank you, Carl and Kate. We had some interesting discussions in the chat with Brian O'Connor from UNCCD, who has provided a link on the 5-star data, enhancing how the encoding can help and support the usability and reusability. I think we will have the opportunity to discuss that in the dialogue about usability. I think that, Dor, you had a question. We will have to speed up to make sure that we can discuss after Lars' presentation also, please.
Thank you. To make this really brief, this is probably a Daniel question, although Kate can field this. We are using citizen science data and trying to make it open. And of course, there's a lot of, when your sensor is not a satellite, but a person, this creates a whole different world of privacy issue. Of course, the data is anonymized, but this still leaves the caveat of when you want to use the data commercially, then it sort of opens up a whole new world of legal issues that concern the intention of the website. If it was initially for research purposes, and then you make it open, and then there's a secondary use that is commercial, how do you handle that legally? From a legal perspective, you have to sort of standardize the way that you go about dealing with this.
Daniel, you want to answer?
Yes, indeed. If I got this question right, it's really data created in a research environment where the data is free, maybe with restriction for research, and then it would be used by businesses for doing its own businesses. That's the point. I must say that, I mean, for Copernicus, the inspiration was, of course, I mean, as I said, Landsat, but also the free software. a big principle for the free software is not to have specific usage of the data. Is really to open to everybody in each field, provided that it is legal. We needed to say that in our data policy. But other than that, anything, it could be in nuclear energy used or whatever, and any kind of activity could use our data. So they were not that type of restriction. Even the commercial, non-commercial restriction was taken out so that there is a creation of businesses out of the data which is distributed. It is essential for us as our public authority roles to empower everybody with the data to be able to create either businesses or whatever for the citizens' good. So if there was a specificity for your question, maybe in this context, and furthermore, again, coming from this open source software creation world, there's always been these ideas of incompatibilities between licenses, which could be an issue, and this need to be tackled as well. I mean, of course, Creative Commons, that type of license is helping certainly in this case. We have our own specific regulation giving as many rights as possible to the users.
Okay. Thank you, Daniel.
You're welcome.
Thank you, Daniel. Thank you, Dor. This was an important question because this is the reality of every day for a developer. So I have shared the results of the poll, so I hope you can see them. And I was thinking that the business model was the major bottleneck to share data. It seems that it is standards and API. So I would like to get more engaged with the audience on this topic, but it will have to be out of this session. We don't have the time right now. The second one is for you, Daniel and Barbara, about the legal issues, good credits, input data restrictions, national policies, multiple chaining licenses, as Dor was asking for. So we can see that the licenses, the legal aspects are still to be, I think that we need to make some capacity development resources on that. And eShape has done one recently, but I think we should do more within or out of eShape. Business models come, well, no, first organizational workload. It seems that sharing the data is not the priority. The priority is on building the data, and sharing the data looks like an option. So it's not included into the workload, unfortunately. So skills and time comes after, and business model comes last when we thought it was the first. So we really have to act on the other topics to help people open data. Any comment here, any question, or we can give the floor to Lars? No?
There's a question from Alessandro.
Yes, I couldn't see it. Okay, Alessandro, oh, in the chat, okay.
Yeah.
Yes, I just put it just to not stop you or so on.
Okay.
Yes, I was trying to link in my question to the others that were in the last part of the other participants, in the sense that yes, we have a lot of this data. There are a lot of communities that want to share the data in the GEOS community, but they are not freely available, let's say. So how could we or what we can foresee in order to have the data that are within the GEOS communities and made to be made available at least among the GEOS communities?
It's a question to whom? We have a next poll, which is about what the audience considers are the priority data, which are where GEO should advocate the data sharing, because it could be a priority portfolio of data to try to encourage people to share. Mm-hmm. Can we address that after this poll, Alessandro?
Yeah, okay, no worries.
Yeah,
okay.
I can just make one quick comment, and that is that this is also a question of interoperability and the guidelines that we have the GEO guidelines, data management guidelines. And I think this is something that we can bring up. Well, we are discussing it in the data working group already. But this is definitely an interoperability issue that is constantly on the agenda, but we can be better at it.
Okay, thank you.
So I would like to give the floor to Lars, and then we will follow up with this question. Lars will bring is working with WMO, and he has been with the WMO Secretariat since 2014, and he is currently the director of the WIGOS branch, leading the Secretariat support for all the WMO observing system activities. So you can understand the very strong link Lars has with the issue we are discussing here. And WMO has a long experience in data sharing and defining the catalogs to share. So Lars, you are very welcome to share your experience.
Thank you. I could not unmute myself,
Okay.
so I could see, but it seems to be working now. So I'll start from this motherhood statement here that weather and climate know no boundaries. So in a way, advocating for data or understanding why data sharing is important is very easy in meteorology. We know for 200 years that there's really no other way to make weather prediction than by exchanging first observations and later on other data globally. It's illustrated in many ways. There's a simple example here showing how lack of data on one side of the world will lead to a degradation in weather forecast skill on the other side of the world. It's just one of many ways of illustrating how interconnected the atmosphere makes all of us. So any hiccups in the data exchange will have an impact on our ability to predict and monitor both weather and climate. So this is well known. If you look at the value chain here, the meteorological value chain, it starts with observations. You need to exchange them, then you need to put them into global models, which is how everything related to weather and climate works these days. Then you do local data processing, you deliver services, and you hope that your users will take action and make good decisions based on the information. Down at the bottom here, this is the reason why you do all of this. This is where you save lives, you protect property, you foster economic prosperity and all of that. But without a functioning infrastructure up here at the top, none of the good stuff down at the bottom will happen. And in meteorology, everything that is in red up at the top needs to be addressed globally. So that's where we start from. International exchange of data is actually one of the reason why WMO was founded. It's enshrined in the paragraph 2 of our convention, which states the purpose of the existing of the organization. It is to develop systems for acquisition of observations and data exchange. It takes a lot of things to actually get the data exchange to function, as we've heard here today, but I'll focus just on the things that are listed in blue here. What is the role of data policy and what is the role of regulatory material? Data policy is sort of the general commitment of national governments to do certain things for certain purposes. But in order to really make it happen, you need to go one step beyond the data policy. You can think of the data policy as the equivalent of the GEO's data sharing principles. It's very nice and it's easy. Well, I don't want to say it's easy, but it is relatively easy to get people and organizations, members participating in organizations to agree with the principles. But to get them to actually do something is often a slightly different kettle of fish. We revamped our data policy. We, WMO, revamped it completely at our extraordinary Congress last October. After having sat on it basically for 25 years without doing anything with it. We had Resolution 40 that many of you are familiar with that had guided the data exchange in WMO for a quarter of a century. Why did we agree to reopen the discussion in 2021? There were concerns about the lack of in situ data in particular. I'm going to get back to that in one of the later slides. Some of you have seen this speckled slide here with spotty data coverage around the world. We needed to move beyond our traditional realm of just weather observations in order to facilitate Earth system modeling. And finally, there were both some opportunities and challenging related to the growing role of the private sector in meteorology that necessitated urgent action from our side. We did a lot of work leading up to Congress. Some of you were involved in this, but at the end of the day, WMO basically restated and enhanced its commitment to free and unrestricted international exchange of Earth system data. This is fundamental. This is very important, and it expands now beyond just the Met services. It includes everybody. So free and unrestricted international exchange of data means free and unrestricted. It doesn't mean just exchange between Met services. It means that the data that are acquired under the auspices of these WMO collaboration agreements are freely and unrestrictedly available to everybody. We still have categories of data, some that are mandatory for exchange and some that are recommended for exchange, and there's a lot of other sort of fine print material in the data policy. It's an 18-page document, but the principle of free and unrestricted international exchange is there, and it's important. Back to the reason why we did this. We have, this is an example of data exchange plots that we generate operationally. We do one of these every 6 hours. This one here is from May this year. It shows how many surface pressure observations, so just simple barometric pressure observations, were exchanged with an NWP, the Numerical Weather Prediction Center, on the 8th of May at a certain hour of the day. Green is good. Everything that is required is exchanged here. Orange is okay. We're not completely pleased with it. Red is not good. And black means that we are not seeing any data there. So this map is much more inhomogeneous than it should be. And that ultimately limits the ability of all of us to do the best we can with weather prediction and climate monitoring. The effects locally, where there are mostly black dots, are actually very severe. You can still do weather prediction. You can download apps that will give you a weather forecast, even in areas where you don't see any data exchange. But it is based completely on modeling and satellite data. So the weather forecast may not be all that great. And it is not verifiable because you use the observations also to verify the forecasts. So not only can you not do a great forecast, you can't verify it, so you can't learn. And you also cannot really get a solid handle of what the climate even is in these regions, because you use the same observations for climate monitoring. And one of the effects of that you see in the IPCC assessment report, where they're telling us that in a lot of the global south, there is not enough data to make a good projection on whether the heavy precipitation, the frequency of heavy precipitation will remain the same, it will increase or decrease. So this is an important discussion in the context of climate adaptation. What are you adapting to? How can you design an adaptation strategy if there's not enough data to tell you what you're adapting to? What WMO did in reaction to this is they decided to regulate it. So they adopted regulations for something that is called GBON, the Global Basic Observing System, that specifies requirements for how many observations of what type you are required to install in your country, and that puts international exchange of data on a mandatory basis. This was a major breakthrough for WMO and for its 193 member states, but it was necessitated by this spotty data coverage and by the steady increase in demand for observations of all kinds related to weather and climate. Of course, there are reasons for why the observational data coverage is not good. Here, this is a density map on the left, where you can see in red the countries that do not have a required density of observations. Blue is good, red is bad on this map here. And on the right-hand side, you can see why. This is a resource map. GDP per square kilometer. So basically how many dollars are being made in the country per square kilometer. And you can see the dark red and purple colors in the small island states in sub-Saharan Africa, in parts of South America, line up very well with the red color here. No, this is not rocket science. If you don't make a lot of money in your country, you will struggle with meeting your commitment to making observational data available. So for that reason, we also, together with a couple of our UN partner agencies, established what is called the Systematic Observation Financing Facility, SOF, that has as its purpose to provide financial and technical support in LDCs and SIDS to implement this system here, and not only implement it, to actually run it, to fund the operational running of it in the poorest countries. So that's what we have been up to lately in WMO with data exchange. So to get from the understanding of the fact that we need to exchange data to getting our members to approve a policy for it, and not only a policy, but to actually regulate what we are doing. So the take-home message is here is that our activities span weather, climate, and water, and adjacent areas, and we are seeing a steady growth in demand of data products, and more and more depends on range and accuracy and the fine-scale resolution, which is all well and good. Advocating for data exchange is relatively easy. As I said in the beginning, we have known for a long time that we need to do this because there is no other way to do weather forecasting. So it's very different from the picture that Barb was describing in her opening talk, where there's not necessarily, it's not necessarily easy to pitch why Landsat data should be given away freely. It's easy to pitch why meteorological data should be. But still, it is not easy to convince national governments of the merits of this. Every time a new minister comes in and becomes responsible for a Met service, one of the first things that he or she will do is they will understand that these data have economic value, and one of the first questions they will ask is, "Are you guys crazy? These data are economically valuable, and you are just giving them away." And then you need to go through the whole educational process of explaining why economic value is not the same as commercial value. And in some cases, in many cases, actually, your best strategy to generate value from the data is basically to give them away, as Barb also mentioned. We are active also in supporting mitigation under the Paris Agreement via a new global greenhouse gas monitoring initiative that I don't have the time to speak about here. But I want to stress finally that data exchange is critical for both the adaptation and mitigation work streams under the Paris Agreement. And we are working to get recognition of that under the COP and the CMA. It was recognized by SAPSTA in its conclusions from Glasgow last year. And our position is that without free and unrestricted exchange of data, talk about transparency under the UNFCCC agreements are largely meaningless. There is no access to a common truth. There's no possibility to verify anything. So we believe that it is vital to get recognition of this under the COP. And I'll stop here. Thank you very much.
Well, thank you very much, Lars. This was very enlightening. Well, we know that advocating data sharing is a huge challenge. You show that even if we consider that in the Met community, this is already a success, even if the Met community can demonstrate the benefits and the value with the forecasts and so on, it is an endless fight, an endless,
constant battle,
persistent, yes, a persistent effort that has to be implemented. And you still look to have a lot of challenges. So this is very, very enlightening. We will go to the end of the poll. While you were talking, we did a poll to ask which type of data people would like GEO to advocate to be shared. The idea here would be to try to focus the efforts on a certain type of data. Without any surprise, in situ comes first. This is something we also found in the eShape project, that there is a lack of global in situ network. This was also part of your presentation, Lars, I think.
Lars, can you unshare? Because I think, Marie-Françoise, you are sharing the results or trying to share.
Yes,
Voilà.
I share the results.
Yeah.
Remote sensing comes second. I think it's just because remote sensing data are already shared. This is why it comes second, because if not, it could come first also. The thematic essential variables, this was a proposal we have put because if we have to define a priority catalog baseline of data, I thought that this could be one of the priorities, but it seems that in situ comes first. And real-time data or historical data, I can see they arrive more or less at the same level. And citizen science data after in situ, even if it's a complement, it can be considered as a complement of in situ. Any comment on this, Paul, Lars?
No, I mean, I showed you in situ data because that is the most difficult thing. Satellite data are mostly shared. I mean, the big agencies have very generous, ESA and NASA and JAXA and many others are actually, they're very good global citizens in terms of giving data away. The in situ data in meteorology, I'm showing you meteorology here, and they are acquired mostly by the Met Services, which actually have a very strong global network. On the land surface side, it is much more heterogeneous because there will be, partly because it's more localized. There's not the same understanding of the essential nature of data exchanging as there is in meteorology. And often it is small organizations. There may be 10 or 20 organizations within a different country that have parts of the land surface in situ observation. So it is a much more complex and much less globally integrated community than the Met community. But you can see even in meteorology the kinds of problems that we are having here. So I'm not surprised at all that I was about to fill out the poll when I needed to start talking, and I would have put in situ data at the top as well.
Yeah. So yeah, please, Bento.
Yeah, I have a very quick question for you, Lars Peter, because I remember that, you know, you have the meteorological community, global community has been sharing data among the members for a long, long time. But the members in this context have been the meteorological organization and not all the organization, you know, not all member countries. Did that change with your new data policy, or is it still the same?
Yes and no. It changed it's a very good question, and I had this problem in my youth when I was working for the University of Copenhagen, and we were doing expeditions on the Greenland ice sheet, and we could not get observations from the Danish Weather Service. They would be happy to share them with India or Brazil or whoever, but not with the not with their own compatriots. That has changed actually. The new data policy says that it is not an exchange between Met services. It is open data. Will the members? It is then all. So these are WMO regulations, but they don't supersede international. They don't supersede national law. So there is a caveat in the text that national law needs to be respected. Most countries, I mean, you know this already, European countries actually have to make data available because the European directives say so. And it is gaining traction in other parts of the world, but we do have a lot of work to do with some of our developing members who believe that they should be remunerated for their data, and some of them believe that they can actually sell observational data to the private sector. We don't have a lot of success stories in that. We believe that the better strategy is to equip the Met services to deliver good services, and they do that partly by participating in the data exchange. And they may be able to sell services. There's much more of a market for selling services than there is for selling observations. So it's work in progress. The new policy says that it is not just between And actually, the members are national governments. They are represented by the Met services, but the members are actually national governments. And the principle now is that it is open data to everybody. And then the implementation within the 193 members, that will be work in progress for a while. That's the best answer I can give.
Okay.
My understanding, Lars, is also that WMO has invested a lot of effort in the ways to open the data at the technological level
Yes.
to more people and more organizations.
Yeah, to use open standards and web-based services. Some of you will know that WMO has historically exchanged data via something called the GTS, which are proprietary networks. It's kind of a 1960s, 70s technology. And we are transitioning now to web-based services and open source software and the open standards. So yes, we are making progress on that.
So yes, the data sharing is also enabled by the technology, by the encoding. We have seen that, as you say, you had your proprietary encodings from the methodology and opening now to the web standards. And we have seen that also with the remark from Brian, that the encoding can also help opening the access to the data and the usability. So we will discuss that in future dialogues too. Well, I knew that we needed more time for this for this session. And Bent and Paola told me, no, we have to stick to 1 hour and a half. So we will stick to that. I'm really delighted to see that the audience have been very engaged through the polls. I'm very happy to have had you, all the speakers. I will have ask everyone to open the video to make a photo, right, Bente? And we need some leaders, as you are, all of you, I mean, Barbara, Danielle, Kate, Einar, Lars, we need leaders like that, bringing their message, giving this example of success stories to open thinking out of the box, to help people share more and understand that what we can see as a bottleneck, an obstacle, can be mitigated. And we might have ideas of more capacity building, right, Bente, Paola, out of the polls. And I hope we will get you on board in future dialogues if we deepen some of these topics.
Yes, absolutely. I'm taking screenshots continuously almost. I'm waiting for people to turn on their cameras.
Yes, please turn on the camera.
Bernd,
you have been an amazing audience.
Diego, Halvad, Dor, are you there, Dor? He was here. So,
and
yeah.
Brian, let's keep in touch if you want to advocate the link you have published.
Yes, and I just repeat what you said, Marie-Françoise. We will discuss so many of the issues that was brought up here, we will be able to discuss in the future dialogue series. You know, every Monday from at 4 o'clock, we will cover the data management principles, and the data sharing will be part of that as well, for sure. I mean, interoperability is part of sharing. Yes, smile.
Thank you. Thank you very much.
Thank you.
Thank you.
Bye-bye.
Thank you, everyone. Bye-bye.
Bye-bye.
Thank you very much.
Thank you.
Bye.
Bye.